All right, can you guys see my screen? Bryn,
Correct.
yes? Okay, awesome.
Yes, we can.
All right, so hello everyone. I am Vadim Peretokin. I am a FHIR consultant here with FHIR. I've consulted on everything from smart and FHIR to national architecture to data mapping. And there is data mapping that an issue that comes up with a lot of organizations. So today we will be discussing a FHIR mapping language, which can help you convert data into FHIR. In this presentation, I'll first of all give you an overview of a FHIR mapping language. Then we'll go through a live demo, they're scary. And we will wrap up by covering all of the parts of a FHIR mapping language and what it entails. So what is a FHIR mapping language in general? It is a standard describing the mapping language. And there is this mapping language that allows you to write mapping files, which are then executed by a mapping engine. So these mapping files take in an input, they get the instructions for converting in the mapping file itself, and they transform it to output. Now, if you've worked with FHIR for any amount of time, you might have seen that every resource in FHIR has this R3 conversions tab on the far right. And down below is some text which looks like code. This is the FHIR mapping language itself. It is in fact used by the specification itself, and this is something that I help volunteer write, to transform all examples from one FHIR version to another. And this isn't limited to examples either. These are real files that you can use to transform FHIR instances from one version to another. Here we see on the screen an example of a mapping file which will take an input patient in R3 format and will convert it to us into R4 format. So how do I use it? First of all, you need the FHIR mapping engine to use it with. You get a mapping file with these instructions, you give it the input and you get the output. And as I also mentioned at the beginning, it is a standard, not a technology. This is important to differentiate. So there is a wide variety of implementations available. There is a choice of Java, C#, Pascal, and even Node.js implementations. What parts of a FHIR mapping standard the engine supports varies between the engine. Not all of them support 100% of the functionality, but in general, they all have pretty good support. And also, when you're thinking of slotting this into your architecture, keep in mind that all engines allow RESTful access, and some also allow direct API access as well. Does it cost? No. The standard itself, like FHIR, is free and open and published as a sister standard to FHIR as an open license. Now, also, if you're implementing FHIR, the FHIR mapping standard itself is optional to implement. You don't have to implement it. But if you're interested in converting your data, you should, or use an engine. Like I've mentioned before, there's a choice of engines. The engines themselves vary on their platform that they run on, and also with the licenses they come with. Some are free and open source, some are commercial and paid. Now, what data formats are supported for conversion? As a standard itself, a FHIR mapping language does not care for the input or for the output format, and I'll show you why later on. But for practical reasons, what the engines support that are available in the market today is converting from one FHIR version to another FHIR version, converting from HL7 CDA to FHIR and back, converting from V2 to FHIR, and some even support CSV to FHIR. And what is the use case? Why does a FHIR mapping language exist? Well, one of the more practical use cases that I've run into in my experiences is that it really helps you with importing non-FHIR data into your FHIR server. Because let's face it, most of the healthcare data out there right now is not in the FHIR format. But by harmonizing it into one format, it really lowers your development complexity. You can just focus on using FHIR in your applications and not have to worry so much about writing converters for all of our languages. But also, why use a mapping language for this? This isn't a new problem. People already have solutions like just writing plain old code, C#, Java, etc. Having written conversion maps, both in the FHIR mapping language and in an usual imperative programming language, I can say it is, first of all, much more efficient. After I show you this example, you'll see what I mean, but it is much faster to write a map to do the conversion than program the same map for it. And also, we as a community all face the same problem of converting similar standards, for example, CDA, to FHIR. And why should every one of us write our own converters for it that fit in our tech stack? What if we could have a shared repository of maps that we could use independent of a tech stack, right? The idea makes sense. This is why a FHIR mapping language exists, and this is why it is a technology agnostic, and the engines themselves are just particular implementations of a standard for a particular platform. So by having this shared repository of maps, somebody can write a map that converts from CDA to FHIR. Those exist, and use it either in a Java stack or a C# stack, or etc. Now, this gives us a bit of an overview of a FHIR mapping language, and I realize that it's all a bit abstract right now. Soon we'll go into an example, but do you guys have any questions so far? After all,
at the moment, the Q&A is empty, but I have a question for you. Is it also possible to have a database, use the database as a mapping to FHIR? So if you have a production database with hierarchical data, can you also use that?
See, this is where the method of access really matters, because as I said, most of the engines have RESTful access, and RESTful database, you see, those don't exactly connect. Some of them also support API access. Not all of them support API access. I imagine with some sort of API access you would, but if you were going to go through the RESTful way, you would have to have a client as a middleman, essentially, to do the conversion, right? You need to reconcile these two different things.
Okay, thank you. I have another question, and I have a question from Baris. Are the mapping languages to convert non-healthcare data to healthcare data? For instance, converting financial health of a patient to social determinants of health.
Can you repeat the question, the start of the question?
Are there mapping languages to convert non-healthcare data to healthcare data?
What really matters is not so much the contents, but the format the data is in. And as long as the mapping engine is able to read the format, then you can write a mapping file to do the conversion.
Okay. Okay. So let's continue.
All right, moving on. Here I have an example of a fake inpatient drug chart. It's a brand new logical model that I just made. You can see it on the left side. And you can see on the right side an instance of this logical model. We'll be converting this fake input logical model into FHIR. Now let's go over this logical model. At first, we see that we have a master patient index, right? Then we have patient name and the date of birth. We also, and as you saw, this is all administrative information. And then next we have height and weight, which is all clinical information. It's not really good practice to mix both administrative and clinical information in one, but we can understand how in the real world these types of records are possible, right? Then we have the drug sensitivities, as in allergies, possibly. And then we also have a prescribed drug field. Now, if you zoom back, you can sort of see how the first half of our logical model maps to the patient resource, right? This is all administrative information. The patient resource is all about administrative information. Then we can see how we can get some observations out of this, right? As well as an allergy intolerance for our drug sensitivities, and medication request for a prescribed drug. So let's go, having reviewed our sample record, let's load it up into Postman. Here it is already in Postman, the same resource that we've walked through. And we're going to use the dollar transform, which is an operation defined by the FHIR mapping language, on my local Wong server here, and transform this input into FHIR output. So if we hit send in Postman, it did not work. Ooh, unfortunate. Let me check the history. Huh. I must have messed up the request. All right, now it works. This is why live demos are scary, but it works now. So out of this, we have a bundle. In this bundle, we have a patient resource, as we expected, with our SAM fireman and his administrative information. We have our observation, which is coded to the loing body weight. And then we have another observation for the body height, the pregnancy status, a medication request, and etc. So you can see how the transformation works. Given our sample logical model, we get a bundle of FHIR resources out of it, just using the dollar transform operation. So let's dig into this. How does it all work? Here we see the FHIR mapping language workflow. And the operation that we just saw is called the dollar transform operation, highlighted in yellow. This dollar transform operation takes in the source input, which can be FHIR, CCDA, CSV, anything. As long as you define a model for it that the mapping engine can understand, it's good to go. And given an input plus the dollar transform operation, we'll get our output. In our case, we had a FHIR bundle back. Now, all of this right-hand side is what happens at write time versus the dollar transform operation. The first half of the workflow is the build time, the preparation that goes into this. And in the preparation, what really matters, and what we'll be covering now, are the mapping rules within the mapping language. These are the instructions that tell the engine how to convert our input into our output. So let's dig into the mapping file syntax. Before we do, two very important points to keep in mind. Maps are one-way conversions. That is, using one map, you can convert, let's say, that logical model to FHIR. But you can't convert it from FHIR back to the logical model. You need to write a second map to do this, right? So the maps are one-way in their nature. If you want to have two-way transformation, you write two maps. And also by default, nothing is transformed. That is, if an element isn't mentioned, it's not going to get transformed. It'll essentially get ignored. So you want to explicitly mention every element in your map in order to transform it. With this information in mind, let's jump into the mandatory parts of a map. So we have four things that are very important to a map. First of all, the metadata that gives us essential information about who wrote the map and canonical URL, etc. We also have references to the structures involved in the mapping. I'll cover this later on. And then we have a series of groups. These groups take input and output variables. And within each group are the actual transformation rules, right? So you can see already how the meat of the matter, so to say, is within these groups that have these transformation rules. So let's start off with the metadata. You can declare your map using the map keyword. After the map keyword comes the canonical URL of the map. And you are already familiar with canonical URLs. They're used in all conformance resources, such as code system, value set, concept map, etc., to uniquely identify that particular resource. So here, this is how we uniquely identify our map. So we give it the canonical URL, and we give it a short name. Next, we will declare our inputs and outputs, as in which data structures are we going to be making use of, using the uses keyword. The way the uses command works is it takes in a canonical URL as well. So in the first line of the example, you can see it says uses structure definition of a fake and patient drug chart. So remember the left-hand model that I previously walked over that described how my logical model looks like? This is the line that tells the engine, hey, go load this logical model. And also important to note is the as mode. So it uses as source, it uses this data structure as an input one. And then afterwards, we have the FHIR resources that we're going to be making use of, like bundle, patient observation, which are used as the targets. So these are the resources that will be outputting input. And here is also a small chart to help you piece everything together. We'll take our fake inpatient drug chart, we'll convert it to a FHIR bundle, and within this FHIR bundle, we're going to have a patient resource, some observations, a medication request, and an allergy intolerance. So what we've learned so far, we can piece together in one example. We can declare our map using the map keyword, and then we can specify which maps we're going to be making use of. Next come the groups, which, as you remember, are the most important thing here. The way the groups work is using the group keyword. Group, afterwards comes the group name, and then you specify which variables this group is making use of. Each variable has a data type after the colon, and it also has an input or an output type specified either source or a target. So a source variable means this is an input variable, we'll be receiving data, and a target prefix means that this is an output variable, we will be outputting this variable. So in this example, here we have a group called make fake inpatient drug chart. It has a source variable called SRC, right? This is an input variable of the type inpatient drug chart. So this variable will be passed to us, and we will output, this is why we have a target prefix, a variable called bundle of type FHIR bundle. The mapping syntax itself within the groups is specified using the left to right operator. So you take the source structure and you pick an element in that source structure. Then you do a left to right operator, and then you say the target structure and which element you want it to go into, which is pretty simple actually. And you'll see how this works in practice, so it'll make more sense as well if it's not making too much sense right now. Now you can also create a value based on expression by specifying the equals sign on the right-hand side. So by doing equals expression, you can do some things. In our example here, we create a patient.id. You see that we don't take anything from the source. We just leave the source almost blank, but we create a patient.id, and then we use the UID function on it to generate a new patient ID. Or we also set the bundle.type element to the word, exact word collection. This is how we can use expressions here. So in our example so far, we define our map, we give it a canonical URL, we specify what data structures we're going to be using with, and we specify a sample group that just creates a new group and gives it an ID, and it sets the bundle type to a collection. Also, you can specify comments in your maps using the C-style syntax, which is / and an asterisk. So have you got any questions so far?
Yeah, Vadim. Also a message for the host. Some people can lost the connection and can't come back any more into the session. So maybe somebody with technical background can have a look at that during this session. Some questions coming up. For example, I take one with the 2 votes. That's a question from Louis Gordon. For the implementation that are not REST-based, are structure definitions resources still used alongside structure maps and the $transform operation? I see it.
Yes, because the structure maps are a way to specify typing information for the mapping engine.
Okay.
So the structure
Right.
map helps the engine know what kind of data it's working with essentially.
Okay, thank you. Can FHIR mapping languages, can FHIR mapping language be used if neither source or target are FHIR data?
Yes, yes, it can be. It doesn't have to be a FHIR output. As long as you have a structured definition, like mentioned in the previous example, that describes the data, you can convert it.
Okay. And the last question for now, what is the Node.js implementation name? Do you know that?
Yes, it is
Asked by Lewis.
it's called FHIR-Kit.
FHIR-Kit.
FHIR kit. If you search for that on NPM, you'll find it. It is
That
published
would
by
be,
the Monster, which are our
yeah.
FHIR
I
partners.
tried to find the link, maybe I can put it in, yeah. Okay, can continue, Vadim.
Okay. So, continuing on the mapping language syntax, we have a keyword called then. With a then keyword, we can call into our groups as necessary. So we specify then, group name, and then we specify the parameters, inputs or outputs of that group. So an example here, we create a bundle entry as an entry, and then within that bundle entry, we create a new patient resource, and we use then transform patient source, which is our source input structure, and patient, which is the patient resource that we just created. So then just below where you see the group transform patient, we call this group with our input data and the patient resource that we've just called. This is how we can continue the mapping language flow. We can also import other maps. So if we have rules defined in other maps, we can use the imports keyword. And again, we specify the canonical URL to identify our conformance resource, as you do in FHIR. And as you notice in our example, it also supports globbing. So you can use the little asterisk to import many maps at once. Now, so far I've explained how to map the data structure themselves, but what about the data within those elements? For example, coded data. Well, for coded data, you can use the translate function. And the translate function has 3 parameters. It takes in a value, the actual value that we want to convert. It takes in the canonical URL of a concept map. And in FHIR, if you don't know concept maps, small refresher, they are a resource that specifies equality between codes. It has a list of input codes and it has a list of output codes, and it says which codes map to which code. So to this translate function, we give it the value to convert. We give it a concept map, which has all of these definitions for code convergence. And lastly, we give it a FHIR data type, because as you know, FHIR has several data types: code, codable concept, coding, which are all codable. So we specify which one of them we want to be created. So in our example, we take the source gender from our logical model, and then we set the patient.gender to something that we use the translate operation on. We pass it a concept map that we've made for this, the my fake patient gender concept map, and we ask it to create an element of a data type called code. So it'll map code, it'll give us a new back code, and then it'll set the patient.gender to that code. You can also have conditional rules using the where keyword by specifying a FHIR path after it. So for example, if we don't want a rule to always run, but we only want it to run under some specific conditions, we can use this. So in our first example, you see that we take the pregnancy value, but we also check that the gender element, a sibling gender element, is set to female before converting it into observation value. This is just to, help us with any data quality issues that might arise. Or another example, we don't take any input data, but we run this rule if the weight element has been filled in. You see where the FHIR path is highlighted, weight.exists. And if the weight element has been filled in, then we create a bundler entry, we create an observation, and then we run the transform observation weight. Now, you can also organize your maps with inheritance. So you can apply rules that are already predefined on this particular data type. And these rules could be in another mapping file, but remember we can import them using the imports keyword. Here we can invoke them before our actual group is called using the extends keyword. So now our group, which is called interaction, we can call and run all the rules that are defined on the backbone element before this group. Those rules will run. For example, it will convert the element ID and something else. And then our rule to transform the code and the documentation will run as well. This helps with organization. Now, you don't have to also define your rules as other groups or in other files. You can also define them inline, which helps you keep things concise. You do that using the then keyword and the open brace. So here we see that we're not defining another group. We're just using an open brace, and then we have some more rules within it. And this is handy because, for example, we take in the sensitivity.reaction, and then we will create an allergy tolerance reaction. But the allergy tolerance reaction in itself is a backbone element in FHIR, meaning that it has other elements within it. It's a group container. So then we go within that container, and then we set the sensitivity reaction to the reaction manifestation using the CC function to transform the code. And then we also convert the data recorded to the reaction onset. This is how we can populate the contents of allergy tolerance.reaction.manifestation and allergy tolerance.reaction.onset using this little embedded nested group. Now, do we have any questions so far before we go do a walkthrough of the mapping file?
Yes, I also like to mention something, that we have some difficulties that people can come back to the session anymore. We are aware of that. We are working behind the scenes to solve this problem. I have a question from Adil Ansari. Any helpful FHIR mapping tools for converting to Turtle? It's one of the formats mentioned for each FHIR resource on the example page.
I will be honest, I don't know of any yet, but it's always possible to create it.
Because I was working on this technical difficulties in the background, I couldn't see all the questions coming in.
There's also one interesting question. Are there communities where FHIR transformations are being shared?
Yeah, that was the one I found. Yeah.
Yeah, the FHIR community, Zulip, come and talk to us. There's a FHIR mapping channel where you can discuss it. There are maps out there that convert from CDA to FHIR. There are maps within the specification itself that convert from different versions. So come and join us in FHIR Zulu.
Okay. Well, so far the questions. I think you can continue.
Okay. So let's go and do a walkthrough of this example, which I've demoed to you live, but it works. Does it still work? Yes, it does. Why wouldn't it work? So here is the actual mapping file that did all the mapping, all the magic in converting. Starts off pretty simple. It has a comment describing this, and it has a familiar map keyword. We will give our map a canonical URL, and you'll see this canonical URL is what we run our $transform operation against. So this is how we tell the engine which mapping file to use with our input data that we've sent to it via our RESTful API. Now we will define all of the input and output data structures that we're using the uses keyword. This helps the engine load that type information in. And finally, we have our first group. And the first group is automatically called for us by the mapping engine. And in our group, we say that we will take an inpatient drug chart and we'll output a bundle. Pretty logical, right? So we will first create a bundle ID using the UID function. And we'll set the bundle type to a collection. And then we will create a bundle entry. Within that entry, we will create a resource. And the resource will be populated by the patient resource. And this patient resource, we save it. And then we call the transform patient group on it using the input logical model and the patient resource. And we don't only call just this one group, we call two groups on it. We also call the transform patient post handler. And for post handler, you see we pass it a few more things. We don't just pass it a patient, we also pass it the bundle that we just are going to be outputting. So let's dive into the first group, the transform patient one. The transform patient one takes in our logical model and outputs a patient resource. Simple enough. It creates a patient identifier using the UID function. And then, this is actually the first bit of data mapping that's happening. We take the source element called MPI, stands for master patient index, and we create a patient identifier. And for this patient identifier, we use the ID function, we pass it the MPI, and we also set the identifier's use to official. Next, we will take the patient name, and we will create the FHIR patient name as a human name. And we'll set the text to the actual patient name value, right? You see how we alias it as patient name, and here we actually use a value to populate the human text. Next, we will use the date of birth element, and which will map into the patient birth date. And we will use the date op operation. We will pass it the input data, the date of birth, which we obtained from here. And we will tell it that it should create an element of datetime. Once it creates that, it'll populate patient.birthdate with it for us. Then we will go over the source contact, we map it to the address, we map the email, we map the telephone in the same manner. And then we'll take the source guardian. If you recall, the guardian is also an element containing other elements in our source input logical model. So we will take the source guardian, we will remember it as a guardian variable, and we will create a patient contact, which in FHIR is also a backbone element, as in a variable containing an element containing other elements. And we will use an inline group, which makes it pretty nice. You see this extension right here, and then instead of scrolling down further, we'll create an inline group. So then from within that nested element, we will take the nested element being guardian. We will take the guardian's name, and we'll create a contact.relationship within our patient.contact. We'll set this to be our emergency contact. We'll copy over the name, and we'll copy over the email and the telephone in a similar manner. Finally, we'll take the source gender. We'll create patient gender, but here's where the translate operation comes in. And the translate operation takes in the gender. It'll take in our concept map, and it'll produce as an output of a type code. Now, how our concept map is defined is pretty simple. It has just 3 codes. So our concept map as an input can take a female, male, or non-binary input, and it'll output us the appropriate female, male, or other code, which are the FHIR codes used in the patient gender. That covers the transform patient group. So at this point, you can sort of get an idea of how we transformed our input data, our administrative input data into the patient resource. But we're not done yet because we still have time in this presentation, obviously. So we have a transform patient post handler group that we'll call afterwards. And this transform patient post handler group has an input of a logical model. It also takes an input patient that we just created, right? And outputs a bundle. Next, it'll conditionally run rules. So if in our logical model the weight element is filled in, you'll create an observation resource, you'll stick into the bundle as a bundled right entry, and then it'll call a transform observation weight function with our logical model, our patient resource, and the output is going to be an observation. So let's jump into this group and see how it works. So here we start creating our observation. The observation has an ID, which we just generate as a UID. We'll set the status to final. We'll set the category to vital signs. We'll set the code to body weight. Next, we will finally take an input element. We will take the weight. We'll create a quantity data type. And we will populate the quantity data type's value with our weight. We will also set the unit in the code to kilos, and we'll set the system to UCOM. So you see how our observation is taking shape. It's actually gotten our value now. But the observation is free floating right now, essentially. It's not tied to our patient, is it? So now we need to populate our observation subject. We do that by taking the original patient ID. This is the whole reason of passing our patient resource that we created previously to this group, so we can have its ID. We take the patient ID, and then we'll create an observation subject, the data type being a reference, and we'll populate this reference with a concatenation of patient/ID. This is how our observation subject will get filled in, and this is how our observation will be tied into the patient resource. Next, height will follow a similar format as the previous weight example. Pregnancy will also follow a similar format. But let's go into this prescribed drug. Whenever we see prescribed drug, we'll create a new medication request instead of an observation. And we will call a transform prescription group on it. Jumping down to the group. Yeah? Hello? Okay.
You still have 2 minutes.
Got it. So jumping down into the transform patient group, we see that it follows a similar template. We'll create an ID, we'll set the intent to our own order, and then we'll set the medication subject as a reference using a similar template before. But here we'll also fill in the medication codable concept. Using the CC function, we will take in the input drug, and we'll create a codable concept with that input data. Now, following that, we also create our allergy intolerance using a very similar pattern as we've seen it here. So this essentially is how our input logical model, which we just created here and defined here, when we call a transform operation, gets transformed into a FHIR bundle with a variety of resources, thanks to this mapping file, thanks to the mapping engine. We have just about 1 minute left, so is there any other last minute questions? And if we don't get all the questions here, I'm also available in the Zulu chat, or you can just email to me as well.
Exactly, and there are some questions about links so that we can provide as well later on as answers in the questions, I think. We should not handle that at the moment. But I have here a question. Can you generate a target profile that reflects what could potentially get created if you run a specified map on a specific source?
Can you generate a target profile? I think I would have to do some, not out of the box, you can't.
Okay.
But with some tooling, you might be able to.
And looking out have for here. Will a structure map validate against the source and target profiles? So will it yell if element names or cardinalities aren't valid?
Yes. Yes. Once you have your... Yep. I believe so. Once you have a structure map for your input resource, you can use a validate operation. I'll use the same rules. On the cardinalities, at least. All right. Okay. Thank you very much. We will take our questions offline because I believe we're at time now. Right, Marco?
Yep, you are.
Excellent. Thanks all. Thanks for attending. Catch you later, guys.